This project was inspired by multiple river table projects. Combining that with a CNC machine ends up with a fairly unique project. It was a gift from my parents and would not have been possible without my friend Brett. So thank you, Brett. Usually the first question when somebody sees the table is what's on the table? So the table is a map of Smith Mountain Lake. And so in order to get that map, in order to put it into a CNC machine, what we needed to do was get an outline of the map and into a format that the CNC machine could use. So we do that by using Google Maps and piecing together screenshots to get an entire picture of the lake. From there, we put it into Photoshop. Using Photoshop, we can extract an outline and get it into a PNG or JPEG format. But the CAD program doesn't take that format. What we need to do is take that outline and put it into Inkscape. I didn't picture that here. Inkscape will take it, convert it to a bitmap, and then extract the outline. And that outline you can use to make an SVG. The SVG format, scalable vector graphics, is what goes into our CAD program. I use Fusion 360 as the CAD program for this project. What you're looking at now is the end result of having taken the SVG from Inkscape, imported it into Fusion, extruded it into a block that's simulating our slab of wood, and now we're ready to do the machining part. Fusion also does the CAM part that we needed, or computer-aided machining. What it does is actually calculate the toolpath that we then take to the CNC machine. The toolpath is what tells the router, the computer-aided router, where to move around and how to cut out what you need. In our case, we chose a 1/2" bit, and what you're seeing is the end result of probably about an hour of computer-aided machining time in order to generate the toolpath. I'm going to simulate it. It's kind of interesting to watch it run. What you're watching is what actually will happen on the CNC machine, although sped up quite a bit. With the 1/2" bit calculated, we're on to the 1/4". As you can see, this gets a lot further into the lake. It goes a lot further north up into the river that makes up the lake, but it still leaves out a lot of the edge detail. This takes about 2 hours for the CNC machine to cut out, but ironically it takes about 12 hours for my computer to calculate. As we finish the 1/4" bit, you'll probably notice that it first started with a complete perimeter. The 1/8" bit that you're now seeing does basically the same thing. It will do a complete perimeter. We didn't figure out what the algorithm it used to figure out which holes to fill in. It's usually the closest, but doesn't appear to be always, so it does some jumping around as you watch. Here's the 1mm tool bit in simulation. It's actually quite interesting. It's got a lot of detail that you can see. This is after it does the complete pass on the perimeter as it starts to fill in some more of the edges. You'll note that, yeah, it still misses a fair amount, but it hits most of them. It will come back at the end and skip around filling in on all the pieces that it missed. Working with Fusion turned into a massive headache, so I was really glad to be done with that and on to actually choosing the slab of wood. It was a lot of fun. Here's one of the stacks that I got to choose from. I ended up choosing a walnut slab. I almost chose a Chinese elm, but I really like walnut. As you can see, the slab had a fair amount of mill marks on it. It's not a very precise machining process. It's more like a chainsaw. But in this case, I used a hand plane and started off. I thought I did pretty well, but it turned into a lot of work. You can see I really smoothed it out, but that was only one surface and I had quite a bit more to go. We moved on and started using the CNC machine for this. It made life a lot easier. We started with the bottom and made that flat and then moved on to the top. The top did pretty well. We used both vertical and horizontal paths in order to get there. It did pretty well. We took off a 16th of an inch at the beginning and then moved down to a 32nd. It required a couple hours of machining time to do this. I was excited to start getting the CNC machine to actually start cutting the lake into the walnut. Here's the very first cut of the half-inch bit into the walnut to start to form the lake. Here's the end result. It's the half-inch bit totally cut through. You can tell it doesn't really look like a lake yet, but it's a lot of walnut chips. Here's the 1/4 inch cutout. You can see it's really starting to form the lake. The first pass is complete, down to 10 millimeters. The second pass is started down to 17 millimeters or 5/8 of an inch. You can really tell the difference between the first pass and second pass here. Here's the completed 1/8 inch pass. I chose to only go down to the 10 millimeter, the first pass depth, rather than completing the full 17 millimeters. It took 2 hours to do this, and I really wasn't going to invest the extra 2 hours to complete the second pass when we'd never see it, and it might add air into the epoxy. You can see the level of detail here. It's quite impressive as you go, and I have a picture of adding the 1 millimeter bit as well. Here's a video at the end of the 1 millimeter pass. As you can tell, it's a lot of detail. The bit's pretty small. We broke about 9 of them during the process, and it took about 13 hours for the 1 millimeter bit to complete. The CNC machine left a burr on pretty much all of the edges. I used a rasp and some files to clean up the edges to leave a nice clean edge so that when we poured the epoxy and sanded it down, we wouldn't see any of the burrs. I also noticed there were a couple of cracks and knots that I wanted to fill so that they'd be clear or black as opposed to having a blue fill of the epoxy. Here's the 50/50 epoxy that I used. It's a half gallon of resin and a half gallon of hardener. I also got off Amazon a little bit of blue sapphire pearl pigment, and you can see a small bucket that I used to mix the epoxy and the pigment. And I bought a syringe to help me get the epoxy into the smaller cracks. I mixed the first quart of epoxy, then we can add the blue pigment. As we stir in the blue pigment, it actually is quite cool to stir up and watch. The powder is quite flat, but the mix is quite impressive. Here's the finished epoxy with the pigment all stirred in. Next step is to literally just pour it in. I poured the entire quart of epoxy straight in. In my research about epoxy, I learned one of the challenges is trapping air bubbles in the finished product. The best way to minimize this is to use a heat gun and get rid of air as soon as possible. This is halfway through the pour, but I didn't want to trap air at this point either. Using a 60 ml syringe, I started to fill in the nooks and crannies. This was important because I wanted to minimize the amount of air that's trapped underneath or inside of the epoxy. As you saw already, we started getting rid of it with the heat gun. We're going to do this a couple more times, but the goal at this point was to fill in the corners of the lake, and then we come back and pour in more epoxy. With the lake totally filled into its borders, it's time to go back and pour in more epoxy. One of the things I'm sure you noticed that I haven't commented on is I use Tyvek tape to basically create a moat around the lake. At this point, I'm starting to fill the lake in and overfill it at certain points. I didn't feel like sanding as much as I could have, and I didn't want it to mess up my shop. So the Tyvek tape is a great way of containing the mess and allowing me to overfill. I overfilled intentionally. I did not want to leave a gap and have to sand down the surface. Or more importantly, I knew I was going to have to sand down the surface. I wanted to minimize the sanding as much as possible. Pouring the epoxy was a process that took between 3 and 4 hours. Obviously, you're not going to see all of that, but there's one more thing I wanted you to note. The lake is formed by two rivers that are dammed. And since it's water, I wanted to get a feeling of flowing water through the lake. I could do that with this epoxy, especially the pigment. If you note, you can see some flow marks of where things are settling and how the epoxy is flowing as I pour it. But I could make this intentional. I used a stick and drew through the epoxy to create the feeling of flow down the rivers. Creating the flow lines actually moved the epoxy from the edges down towards the center. So I ended up refilling numerous times the edges, especially the upper ends of the rivers, so that they were filled with epoxy. This seemed like an endless challenge, but it worked out. It just required a little bit more sanding at the end. I let the epoxy cure for 5 days. It was in my basement, which is cooler during the winter than what the instructions recommend. If I were to do it again, I'd probably let it sit for 2 to 3 weeks, but I was on a timetable to get the project done, and so this conveniently worked just fine. While I really liked the blue epoxy and the look that it gave in this 3D state, it was time to sand it down. I went out and bought a new belt sander. It worked out pretty well. I started with 80 grit, but it wasn't taking off enough, and so I moved down to 60 grit. That worked great. I actually went from 60 grit, got most of it off, then went to 80 grit and went up to 120 and took it down until I was happy with a nice smooth surface. I connected the belt sander to my vacuum. It did a great job of picking up a lot of the dust. I still wore a respirator. I really didn't want the epoxy in my lungs, and I feel that's a good choice. So if you're going to do a similar project, please wear a respirator, and I definitely recommend using the vacuum. Here's the surface at the end of the belt sanding. It looks good. The lake came out well. We can still see tool marks, but I moved on to the hand sander. One of the things I found fun and amazing about this project is as I sanded through the different grits in the hand sander, both the grain in the wood and the lake became much more crisp. The part of the project that I enjoy most is putting that first coat of finish on. You go from a very satin wood to where the grain really pops out. This project was especially rewarding. Unfortunately, I got really excited and I did that without videotaping it. So this is the second coat. It's almost as rewarding. You can get to see what I felt, but it's a little less impressive. Here's the finished table. I enjoyed making it. The legs turned into a mini project themselves, so I ended up leaving them out of the video. I hope you enjoyed watching the video. Thanks for watching, and I hope that this encourages you to try something different and try something new.